again, hopefully you guys see that you guys need to find a mean, which is the n, which is again 87 times the p. That is your mean. And you need to find a standard deviation, which is 3.925264,322. So again, that's the first thing we have before we can do the normal CDF. We need a mean and a standard deviation. And again, anybody still need more time on this one here?
Just a little bit longer.
All right.
Okay, I'm done.
Everybody ready? All right. I take that as a yes. So again, if you look at this thing here, hopefully you guys see that it's very redundant to the previous two, right? They ask you fewer than or equal to, or 25 or fewer, more than 17, and in between, right? And again, in between, you just have to ask yourself, is it inclusive, meaning you include the endpoint, or exclusive, meaning you exclude the endpoint? So let's take a look at this thing here, which is, like I mentioned, your information, your problem give you this two, right? Your n and your p. We find the mean, we find the standard deviation. Now, because they say 25 or fewer than, which is, again, this is what we need to looking for. We're looking for probability of x less than or equal to 25. Again, 25 or fewer is the same as x is less than or equal to 25. And again, once you identify that, hopefully you guys say, okay, let me sketch this out, which is, again, sketch your bell-shaped curve or your small mountain, right? Doesn't have to be nice. And again, this is my 25, which is now where or what item do I shade it? I have to shade it to the left, which is, again, this is what I have, meaning I'm looking for the probability on the left of this item here. And now is very similar to the previous one, which is now, do we include the 25? Do we include the 25, which is in this case, because it's equal to, we have to include the 25. So how do I include the 25? I need to go to the right. I need to extend it a little bit to the right. And how much, which is I add 0.5, which is, this is my endpoint. So I know that my smaller endpoint is -1,000,000. My upper endpoint is 25.5, which is, again, if you do that, if you plug in your normal CDF, which is, this thing should give you 0.9190. Everybody have 0.9190?
Yes.
That's good. And again, similarly, looking at this thing here, approximately more than 14 vehicles have to come back for repair, right? So more than 17 vehicle, which is, again, this thing here does not have an equal sign. It just say X is bigger than 17, right? More than 17. So once we have this thing here, similarly to the previous problem, we just go in and sketch our normal, normal curve. And again, to sketch this thing here, this is what I have, which is more than, I shade it to the right, which is, again, shade this to the right. And once I have this thing here, I need to adjust the 17. Do I include the 17 in this case? No, right? There's no equal sign underneath this item, so we don't include them. And if I don't include them, I have to make this smaller. And again, because it's to the right, to make it smaller, I have to go to the right to exclude this, which is my endpoint will be 17.5. Hopefully you guys see that if you can identify the endpoint, if you can find the mean, standard deviation, and the endpoint, the calculation is very doable, right? So looking at this thing here, I know that the smaller limit, not the smaller limit, the smaller endpoint will be 17.5, and the upper limit or the right-hand side or the right endpoint will be some humongous number, which is 1 million or 10 million, which is, again, you plug this thing in, your normal 17.5, 10 million, the mean 20.01, and your standard deviation, and then again, this will give you 0.7387. I have this.
Yep.
That's very good. And again, lastly, looking at this thing here, because it's exclusive. So the most important thing is we know that in between, which is again between those two numbers, there's nothing other than, they won't be able to tell you anything besides in between, right? So between, which is again, this is what we have. And again, find the probability in between exclusive, which is we do not include the endpoint, which is there's no equal sign, right? So looking at this thing here, we know that again, to sketch this thing out, and again, hopefully the only reason I ask you to sketch them out, right, is to show you or to ask yourself which area we have, right? To the left, my smallest endpoint is some negative number. To the right, my upper endpoint is some positive number. In between, those are my two numbers I'm going to use. But now, because we exclude the endpoint, to exclude the 15, I have to go to the right, and to go to the right, I need to add 0.5. And to exclude the 20, I have to go to the left, and to go to the left, I have to minus 0.5, which is I make my item smaller, which is I go toward each other, make it a little bit smaller, which is now my endpoint will be 15.5 and 19.5. I need to make the endpoint, the adjustment to the endpoint. And if I do that adjustment, this is what I have, which is, again, I have the two endpoint, which is normal CDF, a smaller endpoint, 15.5, and then the big endpoint, 19.5. Everything is the same, which is now my answer is 0.3230. So again, question on this item here. And hopefully you guys see, the second time around, yesterday you only saw it like the last 15 minutes or so. It's a little bit puzzling in terms of what to do, all of those definitions. But hopefully today we see the problem as it is. Hopefully you guys see that, oh, this is the step, this is the process, this is, we need to find this, we need to adjust, and then we use the normal CDF. Question with this item here, or question with anything related to your calculator or calculation here?
Yeah, I have a question with how you're supposed to type the standard deviation into the calculator.
You can either using this, type in your square root, find your square root number, and then just use as many decimal as you want. Or you can just use the square root of this thing here. It doesn't really matter. I mean, for me, I type. Let me see. Give me 1 second. For me, I type it in. For me, I type, for instance, sorry. Second of all, do you have 84 or 83?
I have an 83.
83. So for me, you can type in. You can type in, find your standard deviation first if you want, meaning you take a square root. You see, I hit second square. I hit second square to have a square root, and I can just type in 83 times 0.23 times open parenthesis 1 minus 0.23, and I close it. I can type it this way first to find my standard deviation, which is that the number I'm going to use. And like I say, if you do it this way, just keep as many decimal as you can, at least 6 or 7 decimal. So you can just type a square root, or if you want to, you can type the other one, which is you can just go into your normal CDF and just type in as you see, like 15.5, comma, 19.5, comma, and then you can do 87 times 0.23, comma, square root of 87 times 0.23 times open parenthesis 1 minus 0.23, close them up. I mean, you can type it like this, the way you see it. I mean, the way that the formula have it, instead of do each individual and type that number in, you can type it the way that they have it, which is 87 times 23 as your mean, and then the square root of the whole thing. So it's up to you. Either way, the answer, I type it this way in my calculator, and I have 0.3230. I type it this way, I still have 0.3230. So again, if you keep 6 or 7 decimal places, it should be fine. Is that?
Thank you.
Right.
Yeah, that helped.
Any other question here, ladies and gentlemen? All right, if you don't have question, this is the end of 6.4, which is, again, this is the end of the calculation item we have. Let's take a look at 6.5, and 6.5, as I mentioned earlier, is very small. The information is very small, which is, again, this is the idea here. The idea of 6.5, which is there's not a lot of calculation. If you click on the homework and do the homework, you see that there's not many problem on there. This thing is just basically say, okay, if we collect some data, can we look at this data and search, or can we take a look at this data and say, okay, we can apply the normal distribution curve to this data, to this sample, right? So again, we draw some sample. We don't have the whole population. We just have some sample, and we'll base on that small sample that we have. And we ask ourselves, is it okay for me to use the normal distribution based on this small sample? Remember, in 6.2, in order for you to use the normal distribution, your sample have to be more than 30, right? In 6.5, they say they kind of break that rule, and they say, if I have just a small sample, is there any way that I can estimate and say, oh, it's good, I can use the normal approximation, right? So that's the idea here, which is, again, in order to do that, again, as you can see, there's no right way to do it, because it's not always come out to be 100%. We always estimate this thing here. But in order for us to know if it's a good to use the normal distribution, is this item here, which is, again, you have to look at your data and ask yourself, do you have an outlier? If there's an outlier, we say, nope, you cannot use your normal distribution for that data. If not, is your data skewed to the left or skewed to the right? If your data skewed to some item that is not look symmetric, then we cannot use a normal distribution. And the last thing is, do you have more than one mode, right? If we have one mode, then yes, we can do it. So all this thing here have to not consider. If one of this thing is applied to your data, then we say we cannot use the normal distribution to approximate this thing here, okay? So again, that's the only thing we do in 6.5 is, if we look at our data, if we look at whatever data we have, is there a way that we can say, oh, based on this data, based on this small sample I have, I can use the normal distribution. So to the rule of thumb is if none of these three apply, then yes, we can use it. If one of these three items apply to your data, we cannot use it. Okay. So again, the idea is if you remember the rule of large number is if we have a small, let's say we have 5 data, and you say, okay, based on this 5 data, we can use the normal distribution, meaning again, based on this 5 data, we can do it, meaning if we collect more than 5, if we collect more than 30, then we go back to 6.2. We can apply it because the rule is if we just need more than 60 data to use the normal distribution, we just need to adjust the item, right? So again, this is what we have in the idea of 6.5. So take a look at this problem here, which is again, they give you this data. They give you the 7 data, right? They say that this, based on this 7 data, based on this 7, the thermostat of DIN test, right? We try to test the oven thermostat. And the oven is set to be 360 degrees Fahrenheit, and the temperature of the thermostat turn off is recorded, right? So again, this is the 7 thermostat we have, the temperature we have that when the item turn off. So looking at this data, is it reasonable to apply the approximation or using the normal distribution for this population here if we have to have a population? So one thing they tell you is, one thing you can do is you can construct a dot plot, which is, again, this is the only thing probably you will see is if we want to, we can do the dot plot, which is, again, dot plot is you just go and put a dot, right? And then you look at this dot and you ask yourself, well, based on this dot, do we have any outlier? Do we have any value so extremely low or so extremely high? So looking at this thing here, hopefully you guys see that again. Hopefully you guys see that this data is kind of spread out in terms that it doesn't have like an outlier, and it does not have anything in terms of the security, meaning it doesn't go and all way a lot of data on the left or a lot of data on the right, right? This thing here kind of scatter out and a little bit uniform, right? A 2, 2, 2 in terms of that. So looking at this thing here, we just say, okay, based on this thing here, I don't see any outlier. I don't see any security. And we cannot see that they have more than 1 mole, right? So looking at this thing here, we can say that, yes, based on this item, we can apply the normal, approximately a normal dish to this population, okay? So again, that's the idea that we have here in the sense of this 6.5. There's no calculation. You just look at your data and construct, you know, a dot plot, or later on we construct a dot plot and then the histogram. But look at this thing here. Look at this data. If you were to do a dot plot, everybody see that a lot of your data is around this area, and also one data is way out here, which is looking at this thing here is in terms of this thing here, this is most likely will be your outlier. And if your data have an outlier, then we cannot use a normal distribution. Everybody see that? So again, that's it. That's all there is in 6.5, ladies and gentlemen. They don't kind of, you know, we do all the calculation already, right? This thing here, we just look at our assessment in a sense. And if this assessment look right, no outlier, no skew to left or skew to right, then your data is good to go, right? So looking at this thing here, question in terms of how to determine if we can use the normally approximate normal for the population here.
So, Mr. Tran, real quickly, we just basically going through and we checking all the recommendations, and if we get 1 yes or 1 no, then we can't at all.
If we have 1 yes, it's got to be all no.
Okay.
If you have 1 yes, then you cannot use it. So pretty much this 3 item right here. If there's an outlier, you cannot use it. So it's got to be no outlier, no skew, and no more than 1 mole. The mole is the hardest thing to look for. The mole is probably, this thing here is when you look at the histogram, and your histogram, like you have a two peak, like you have like two mountain, you know, like two of them like higher, then that's when you have more than one mole, then that's more of a histogram. It's pretty much, as you see, before the day over, I let you, I show you how to do it in terms of the item. Let's take a look at this last example I have here, and then I can show you how to use your calculator to construct this. If you look at this bar plot, right? This bar plot item, which is they ask you which of the bar plot below, if any, indicate that you can use the approximately normal or reject the approximately normal, and why, right? So based on A and B, which one can we use it, or if any, or which one can we not use it, and why we cannot use it, or why can we use it?
You
right?
can use it on B, but not A, right?
Exactly. Why not A? Because
Outlier.
an outlier, right? Again, there's an outlier here, and looking at this thing here, it's kind of skewed to the right, right? Again, when you look at it, there's more data on the left, but again, remember, skewness is the graph looking at you, which is a lot of data kind of on this side here, which is again, that's why it's kind of skewed, very strong skew to this item. That's why is we cannot apply this normally, right? And again, over here, yes, is, you know, they tell you that to be precise is not really kind of symmetric, but again, you know, because we just guesstimate and approximate, we say, okay, it's kind of fit the eye test, right? It doesn't have to fit all criteria, but it fit the eye test, is good to go. So, you know, this is just basically the eye test. So when you later on, you know, in chapter 7, chapter 8, when you start to put in the test, and that's where sometimes the error come out, right? Because your eye test and the actual calculation will sometimes does not match, right? But again, this thing here, 6.5 is basically tell you, do this eye test. Can this eye test work? Meaning if there's no outlier, if there's no skew, and if there's no more than one mole, then your eye test good. Basically, that's it. Okay, and that's all there is in 6.5, ladies and gentlemen. And before I let you guys go, this is I typed this thing up. Your calculator can construct the bar plot for you. Okay, meaning looking at this thing here, this is the data on your example 2 when we do the dot plot. So let's take a look at this thing here. This is what I tell you guys to, if you want to construct the bar plot, if you want to construct the bar plot, this is what you need to do is hit stat and then edit, and then type your data in L1, which is, if you remember, this is what we have give me 1 second. So this is what I ask you guys to do is, if you want to use your calculator, which is some of your homework question asks you, they only give you the data and they ask you to verify if you can use it or not. Okay, so given this thing here, to type this thing or to create the bar plot, this is what you need to do is you need to edit your data first, which is you hit stat and you edit, and then you type in your data in L1, which is my data is 68, 71, 79, 98, 67, and 75. So again, this is my data. I have 6 data. I type it in. Once you type in your data in L1, now this is what you need to do is you need to hit second, y equals, which is again, y equals right here. You hit second, y equal, now this is your stat plot, which is, again, you can choose any plot. So we can only choose, you can choose any plot. Let's choose number 1. So to choose number 1, we just press enter. And then make sure that you turn on right here. Everybody see that select on. When your on light blink, you press enter.
We can't see your calculator.
Oh, you cannot see it? Sorry. I thought I shared the screen. Now you guys see it?
Yes.
Yeah, it's there.
Okay, sorry. I thought I shared this screen, but I guess I share. So again, you hit stat, enter, and you type in your L1, which is right here. So I did whatever I told you. And again, second y equals up here. Everybody see second y equal. So if you hit second here and y equal, this is the y equal button, which is, this is your stat plot, which is, again, you can choose any number. So just choose number 1, that's fine. You just press enter. And now, like I mentioned, on your own item right here is have to be blink, and you have to select that by pressing enter. And then you go down to the type, and then you choose, you press arrow, just press the right arrow, don't press the down arrow, either the left or the right arrow, which is, again, we want to choose this item right here. This is the modified bar plot, which is the 4 items. So if you go 1, 2, 3, this item here. And later on, if you, on your homework, if they ask you to construct a histogram, this is your histogram item that you have. So again, we're choosing this modified bar plot, and then you press enter. So to make sure that you have this thing darkened. Everybody see that my item right here is darkened. And again, everything else is good. Everything else is good to go. You don't need to do any changing. Okay, so again, the only thing you need to do is select on and choose the right item. If they ask you construct the histogram, you construct the histogram for this one. If you want the bar plot, this is the bar plot. Now, how do you view them? To view the bar plot, you have to press zoom. You see zoom right here, you just press zoom. And then you press down to zoom stat, which is number 8. So again, you press down to zoom stat, which is number 9, and then you press enter, and they give you this bar plot. And again, as you can see, this item, last time we say we cannot use it because there's an outlier, which is this thing indicated we have an outlier, which is, again, 98 is your outlier. So again, because we have an outlier, that's why we cannot use in this, we assess and we say, no, we cannot use the normal distribution for this data. Okay. So again, I have this type up here, and like I mentioned, I will post this thing on Canvas tonight, so you will have it. But again, I know it's a lot of things to type in, but this is one way. If they give you this item here, then life is good, right? If they give you this item, then life is good. You say, okay, there's an outlier, we cannot use it. This thing here look kind of okay, we can use it. But if they don't give you, and they just give you the data, like they just give you this number, and they say, given this data, can you verify if we can use it or not? Can you verify if we can use the approximate normal population for this data? Which is, again, one way you can do is you can use your calculator to plug it in, and then you can look at your plot and see if there's an outlier, or if you let's see, this one here, I don't think the histogram will give us any good indicator. But again, you can just use this histogram, and then you still do the zoom. I think this thing is scatter, which is right. So that's the histogram we have, which is, again, it doesn't seem like it's uniform, so that's why we don't have it. So again, you can choose the histogram, or you can choose the histogram, or you can choose the bar plot. for your calculator. Question of how to use your calculator to tell your calculator to graph this. In your book, they also have Excel. Excel can also graph this thing here. Like I say, 6.5 is just tell you there's a method that you can assess them, right? There's a method that you can, instead of do the calculation, we just want to verify if we can do it or not. Okay, and that's what 6.5 is. It's not really important. It's just one way for you to kind of eye test it out, right? So question with 6.5 here, and like I said, 6.5 is very short. That's all there is in 6.5. If they fit, if none of this criteria work, then we can do it. If one of this criteria is there, existent, then we cannot use it. Okay, so again, basically, no outlier, no skew to the left or to the right, and no more than 1 mole.